Welcome my friends and viewers. In previous two videos, I have dealt with the regression analysis, and prior to that I explained correlation analysis in just quite detail. In regression analysis, first of all I explained the very relevant theories, and then I solved few sums. So in yesterday's class I solved two sums. In today's class I am going to solve these three sums, and in next video I shall be solving some MCQs of regression and correlation. So these three sums I am going to solve today. First sum is, we have the given data, rainfall and yield. We have the mean and SD of rainfall and yield. Here correlation coefficient between rainfall and yield is given at 0.8. Then it had been asked that find probable yield when rainfall is 29. So this is what the sum is now. When solving, give names to these two variables x and y. So absolutely this is x bar, this is y bar, this is standard deviation of x, this is standard deviation of y, and it is rxy. So for any given value of y, we shall be estimating x. Now in this sum, we have to estimate y for any given value of x. X is 29. So we have to estimate y. So we are supposed to calculate regression equation of y on x. Let this equation is alpha plus beta x. Depending upon the nature of the sum, it looks quite obvious that for finding solution of this sum, the third formula of least square method, just in terms of correlation analysis, which I have explained in the class, that formula would be used, and from there we shall be using the regression equation of y on x. So we have to estimate alpha and beta through the very correlation formula, and if we do remember, beta was r into sigma y by sigma x. R is 0.8, sigma y is 6, and sigma x is 3. So this is 1.6. Beta slope has come out to be 1.6. Now we have to calculate alpha, and alpha is y bar minus beta x bar. Everything is given. Y bar is 40. So 40 minus beta, that is 1.6, and into x bar, and x bar is 25. So this is 40, and 0. So alpha turns out to be 0, hence regression equation of y on x, y was alpha plus beta x, alpha is 0 without any intercept, so this is 1.6x. Now from this one we can estimate that if x is 29, we have to estimate y. So simply in the regression equation of y on x, the value of x would be put as 29. So y would be 1.6x, that is 1.6 into 29. So this is 46.4. So this is what it was asked in this sum, and depending upon the nature of the sum, we have to pick up the formulas, because we have the three forms of least square method. In this one, this correlation form of the least square method would be used, and this is what is the answer. Now come on the next sum, second one. Here it is given that summation of x is 5, summation of y is 4, sum of squares of deviations from x bar is 40. So this figure has to be decoded. In this sum, it is given that, of course it is 2, sigma x is 5, sigma y is 4, sum of squares of deviations from x bar, hence it is summation x minus x bar square, sum of square deviation from x bar is 40. Next one, sum of squares of deviations from y bar, so summation y minus y bar square 50, and sum of products of deviations from x bar and y bar, so summation x minus x bar into y minus y bar, and this value is 32. So the given sum in the form of languages has to be decoded in this way, and the number of pairs of deviations, observations is 10. So n is 10. This is the given data. Now, what has been asked, find byx. This is the regression coefficient of y on x, for which we shall have to calculate regression equation of y on x, y alpha plus beta x, and everything is given in the form of deviation. So if you do remember, my students, here deviation form of the OLS formula would be used. So if it has to be remembered that beta was summation xy divided by summation x square, all the smaller letters. Now this summation x minus x bar square, summation x minus x bar square would be written as summation small x square, that is 40. This would be summation y minus y bar square, it is summation small y square 50, and this is summation x minus x bar into y minus y bar, this is summation xy, and it is 32. So these data has to be picked up. Summation xy 32 and summation x square 40. So it is absolutely 0.8, and alpha is y bar. So it has only been asked byx, then not to calculate alpha. This beta is byx. So byx, this value we have found, it is 0.8. Now regression equation of x on y, that is x is a plus by, and by is defined as summation xy by summation y square. So 32 divided by 50, 0.608 0.604, it could be taken as 0.6. So this b is bxy, regression coefficient of x on y, it has become 0.8, and these two answers can be checked. We have seen that bxy into byx must be less than 1. It is 0.8 into 0.6, 0.48, less than 1, it's okay. So this is bxy 0.6. And third is rxy. We have seen that r is under root byx into bxy. So this is 0.8 into 0.6, 0.48, and approximately it is 0.7. So this is how we have calculated byx, bxy, and rxy with the help of these formulas. Here deviation form of the OLS method has to be used, and this is how we calculate different things. So this was the story of sum number 2. Now sum number 3. What sum 3 says, that we are given two regression equations, and from those two regression equations we have to find different things. So let us write first. 10x plus 3y is 25, and second equation is 6x plus 5y is 3. Right. First has been asked that find mean x bar and y bar. Here a little bit of theory is involved. In least square method, this is x bar, this is y bar. Theory says that both lines of regressions, this is y on say, this is y on x, this is x on y. So both lines of regressions passes through the intersection of two means. So one just coordinate of these two would be the x bar and y bar. This is x bar, this is y bar. So the intersection of these two regression lines gives us the means of x and y. So simply we have to find the values of x and y just by solving these two equations. So 10x plus 3y, 25, and 6x plus 5y is 3. So 3, and if it is multiplied by 5, so 30x plus 9y is 75, and 30x plus 25y is 15, 6y is 60, y is 10, that is y bar. We have got the value of y bar 10, and this value has to be substituted in any equation, either in 1 or 2. So from 1, x would be 25 minus 3y divided by 10. 25 minus 3y divided by 10. No. Sorry. Just that was a slip. This is minus 25y. And this is minus 16y. Hence, y bar is somewhere, some looks to be erratic because data is not just in the conformity of the sum. 10x plus 3y 25, 6x plus 5y is 31. So if this x has to be eliminated, this multiplied by 3 and this is 5. So 30x plus 9y is 75, and this is 30x plus 25y, and this is 15. Y bar is turning out to be negative, which is unacceptable in statistics.
Sir, it is 31.
Which one?
6x plus 5y is equal to 31.
What is that? Oh, that's why such kind of thing is coming. Yes. So sorry, it was an omission on my part. Mean can never be negative. That's why it was just a problematic for me. So 30x, yes, now 9y is 75, and 30x plus 25y is 155. Now we shall get yes. So minus 16y is 0, 8, hence y is 5, that is y bar. Y bar has come out to be 5, and now this value has to be substituted in any of the equations. So from 1, x is 25 minus 3y and divided by 10. Yes. So 25 minus 3 into 5 divided by 10, 10 by 10, 1. So x bar is 1. Hence, x bar is 1 and y bar is 5. So x bar is 1 and y bar is 5. This is how we calculate means if the two regression lines are given, and this theory has to be kept in mind that both regression equations intersect at the intersection of two means. And this very theory has been used here. So we have got the value of means of x and y, x bar and y bar. Now we have to calculate Rxy. For calculating Rxy, we must have the knowledge of regression equation of y on x and regression equation of x and y. So from these two regression equations, we shall have to identify that which regression equation is y on x and which regression equation is x on y. And in identifying those two regression equations, this theorem has to be kept in mind. This will guide us in identifying some. So, regression equation is 10x plus 3y is 25 and 6x plus 5y is 31, equation 1 and equation 2. Right now we don't identify that which one is y on x and which one is x on y. So just we can start randomly. Let equation 1 is y on x, and if it is y on x, then it has to be arranged in the form of alpha plus beta x. So 3y is 25 minus 10x, hence y is 25 by 3 minus 10 by 3x. So byx, or we may call it beta, has come out to be 10 by 3. And if regression equation 1 is y on x, then definitely this is x on y. So 2 is x on y, and if it is x on y, it has to be arranged in this form, a plus by. So 6x is 31 minus 5y, and x is 31 by 6 minus 5 by 6y. Here bxy is 5 by 6. Now let us check it whether we have gone in a right way or wrong way. So beta is 10 by 3 and bxy is 5 by 6. 50 by 18 greater than 1, so we have gone the wrong way. In fact, equation 1, which we have taken y on x, is x on y, and so equation 2 is y on x, so this has to be reversed. Equation 1 is x on y. So 1 is x on y, and if it is x on y, then a plus by, this is 10x is 25 minus 3y, hence x is 25 by 10 and minus 3 by 10y. Hence bxy has come out to be 3 by 10. And so definitely equation 2 is y on x, which needs to be arranged in this way. So 5y is 31 minus 6x, hence y is 31 minus 6 by 5x. So byx has been found to be 6 by 5. So let us check it. 3 by 10 into 6 by 5, 18 by 50, and 9 by 25, 0.36 less than 1. So this has been the right way. Hence Rxy is under root bxy into byx. This is 3 by 10 into 6 by 5. It has been calculated as 0.6, hence R has been found as 0.6. So this is 0.6. R is 0.6. Next stage, sigma y, standard deviation of y. So bxy, b 3 by 10 and beta 6 by 5. All right. So now we have to find out. We have the data on variance of x is given, that is 4. So from that we have to calculate the standard deviation of y. Now the standard deviation of y, for finding this, we shall have to use the formula of either B or beta. Beta was defined as R into sigma y by sigma x. Beta is 6 by 5. R is 0.6. Sigma y has to be calculated, and sigma x, variance of x is given as 4. So sigma x would be 2. Now get the cross multiplication. So 12 is 3 into sigma y, and sigma y is 12 by 3, and it is 4. So 4. And fourth has been asked, standard error of estimate in regression of y on x. There is a formula here. Number 4. For y on x, standard error, you simply write here yx. That will suffice the need. It is sigma y into 1 minus r square. This is a standard error for y on x. Had it been x on y, so standard error x on y would be sigma x into 1 minus r square. These two formulas must be kept in memory. Here this has been asked, that standard error of estimate in just regression of y on x. So standard error of y on x, sigma y right now we have got as 4, and into 1 minus r square, 1 minus 0.6 square, that is 4, 1 minus 0.36, that is 4.64, 4 into 0.8, and finally we have got it as 3.2. So this is how we get the value of standard error of estimates, either y on x or x on. Had it been on x on y, we would have gone by this way. So in today's class I have solved these 3 types of sums, and for today's class this is all. In tomorrow's class or the next video, I shall be dealing with the MCQs related to the regression and the correlation analysis, which I shall do in the next class. For today, this is all. Thanks.